Chapter 13, Stairs and Levels, in which we get to navigate between multiple dungeon levels. There seems to be no way we can survive the cats assaulting us. Maybe we could flee down some stairs. Stairs look like this. Stairs down and stairs up. First, let's add them to glyph. And for glyph inf, we have to add them too. We will place stairs next to the player. We'll need a new builder, so clone 12 builder C into 13 builder 2D, and remember to rename the class, then insert this. This level 0 special case is tied to fleeing from flock of cats. It will place the stairs a few squares away from the player. Now call add level stairs and make level after the call to add player to map, like this. On all other levels, we will instead place stairs randomly, both an upstair and a downstair. For this, we implement the add stairs method. For add stair to work, we need the free space tool, which will help us find tiles of specific kinds, for example an empty floor tile or a wall tile. We must add equal to wall point. To test our stairs, we then make index 13 stairs. And voila, we have stairs. They don't do anything yet though. When a mob steps on them, he should go down or up the stairs. Here, we'll just let the player use the stairs. In theory, we could make the enemy monsters react as well when they step on stairs. By default, stepping on stairs should probably make monsters disappear from the level, a bit like a trap. It would be the obvious thing to do, but not very logical. Why would an enemy leave by stairs if he was busy chasing the player? Note that it could make sense if we wanted enemies to follow the player when he flees by stairs, but then fleeing through stairs would be much less useful to us. We must choose between several possible places to implement stair travel. We could implement it directly in pass player. Here we know we are dealing with the player. Or inside move command, or with its own command used from move command, or in yet other ways. We choose an own command, chained from move command. We like commands because they form our general and reusable spells. A command lets us reuse this go to a different level effect in other cases. Mobs know whether they are the player or not, so that won't cause us trouble. Tying it to move command makes the stair effect general, in case it should affect both NPCs and player in some way. When triggered through move command, it's caused by the stair glyphs. When triggered by calling stair command directly, no stair glyphs are required. In move command, we change execute to be this. And we add the method deal with stairs. What walking downstairs does. We finally have to deal with the actual stair walking. What should happen when the player walks down a stair? Well, he should arrive somewhere on the next level. This is where roguelike traditions weigh heavily on the game mechanics, and game logic trumps proper logic. A naive person might assume there would be stairs back up where the player arrives, the property of connectedness. A naive person might also assume the player would arrive in the same place if he descends the same stairs twice, the property of consistency. Nobody can forbid you to implement that behavior. But here's how the game logic reasoning goes. Stairs offer a special trade. At first look, they offer an escape and even a form of reward. If you are being chased by a monster and are low on hit points, Fleeing by the stairs appears to bring you to safety. Given that the game is about progressing forward through the levels, exiting by stairs you have found is also a kind of reward. You can now proceed to the next level. Because of the advantages, stairs that were also consistent and connected might pose a cheating balance problem. For example, you might handle dangerous monsters just by continuously stepping up and down stairs, alternating between hitting the dangerous monster and retreating by stairs to heal in safety. Arguably, this could be addressed by making monsters follow you through stairs. But again, by roguelike traditionally, monsters do not follow you through stairs. Instead, it is tradition to tie some risks to stage reversal. The oldest or most popular tradition dictates that levels are shuffled by stage reversal. You cannot step in the same river twice. This means that every time you go down a level and then back up again, you would arrive at a new level, new version of that level, not back at the same level you started from. There are two aspects to this. A long time ago, this spared the weaker computers of having to use storage to keep all those levels for later. If you can't ever return to a level, I don't have to keep it in memory for later. The other aspect is that it tightens gameplay. If there's some dangerous but potentially lucrative content on your current level, you must handle it with the resources you have if you want those rewards. You can't go back for reinforcements to play it safe. The disadvantage of shuffled levels is that everything becomes temporary. It hurts continuity. You can't find a point of interest, for example a shop or a wizard, and then return to it later to sell or buy stuff or complete a quest. For these reasons, some old games, for example Moria, used a limited persistence. You could teleport between town level and a single current remembered level, but not between arbitrary other proper levels. One perspective on that design is that town level never was a real level. It was more like a navigable inventory backshop you could walk around in. The town level is a gaming system loop mechanism. A milder risk version is to keep the levels persistent, but shuffle where the player arrives. This gives some of the same design benefits. This way, it's still risky to traverse stairs. You don't know where you'll arrive, maybe right into a group of dangerous monsters. You can't immediately find stairs back once you arrive, and even if you have successfully been to the level before, you may have to search for the stairs again. You could make it further difficult for the player to reorient himself on an earlier visited level by clearing his memory of the level map or where the stairs are. One advantage of persistent levels is that it inhibits scumming play. You can't continue to replay shuffled version of the same level to amass loot in an unintended safe way. Instead, you are forced to delve deeper to find further loot. This background on dungeon stairs informs some of the challenges we face when implementing the class which will hold our maps, the dungeon class. If we chose to always shuffle level maps, the implementation could be simple. Just a current dungeon level number and the ability to generate maps for any given level on the fly. However, here we will choose persistent level maps, so we'll also need to track an array of stored level maps. In fact, we'll make a new dungeon class dungeon to hold our collection of level maps and to help us travel between them. Deterministic stair travel would be easier to implement, but we want the shuffle travel where the player arrives at random locations each time. So we must avoid leaving multiple older copies of the player around the maps. This issue did not exist when we only had one map. A question of exactly how to enter and exit a map level. To formalize our approach, we can give maps the methods enter map and leave map. However, leave map collapses to being just remove mob. We can then give the dungeon class the method player switch level, which will use those methods in an orderly way. To sum up our requirements for the dungeon class, hold a current level number, an index into the map array, manage an array of dungeon maps, generate maps on the fly on first reference, and deal with player switch level. Behold 13dungeon.ts. We'll have to account for intermap in a bit. To make this work, we must also adjust game and game interface. Game interface gets these dungeon property and builder property. For the actual game object, we'll clone game 1 into a new class game 2 and adjust it majorly to look like this. We have removed the property map which game 0 had and instead delegate to the dungeon. The player has been made a proper constructor member, and we have added build if as a property. We must update builder 2D to use this game 2 instead of game 1 by changing make game to this. Note that the builder no longer directly provides the game object with a build map level. People still call game if.currentMap, but it now changed from dungeon.currentMap to the builder. If we ask for a dungeon level that has not been referenced yet, the dungeon uses a builder to construct new map levels. For this, the game must hold a builder, so additional levels can be built on the fly. We must scout out the new map beforehand to find a vacant position to put the player in. Beware the player can only manage this position for one map at a time. Assuming our game model has the dungeon design outline above, our stair command will now look like this. If you try this out, it should now be possible to flee to different levels. However, all our levels look the same. The only difference is that the enemies return to their initial starting circle. To help orient our player a bit, we will extend the draw map render stats to also show which level he is currently on.